Network analysis. Network analysis is a topic that is mostly applicable on projects. As you undertake the projects, we are going to have different activities which are interlinked, which at the end of the day, when we undertake them, all those activities or tasks, when we undertake them, we are going to bring the project into completion. So here we have a combination of activities represented by an R. We also have what we call events, which is which are represented by circles. The event, it is the point in time where either an activity is starting or an activity is coming to an end. When an activity is coming to an end, there must be a circle. When it is coming to an end, there must be a circle. So when we now draw a diagram with these activities and events which are interlinked, we are going to have a network diagram. That network diagram, it is like a pictorial representation on how the project will be undertaken from when it is going to start to when it is going to come to an end. In our previous class, we introduced this particular topic. We talked about the rules of drawing the network. The network will start from left to right. We said the activity can start when the preceding activities have been completed. We said we should avoid the issue of danglers and the issue of loops. And a loop is whereby the project moves forward and then it starts moving backward. This is a loop. We should avoid scenarios like this. The project should be forward moving. We should not get to a point whereby now again we are moving backwards. It should always be forward. In case we are going to have that the activities are not interlinked or there is a hanging activity, what we call the danglers, we should also avoid them. At one point, we are going to incorporate the dummy activities, which we said is an activity that does not consume time or resources, so that the logical sequence of the network can be upheld. All this will be in the network diagram. So today, our task is very simple. I want to show you how we draw the network diagram, how we get the duration the project will take, and also how we can identify the activities we call critical activities. Critical activities are those activities which, when combined, they will give us the longest duration of the project. Those activities which, when one of them is delayed, the entire project is going to be delayed. So that is where we are today. I want us to start with a question that is on page 9. There is a question that is on page 9 of the past papers. Page 9. There is a question there. There is a question there. Question what? Are you able to see what is on your screen? I'm interested with this question 1B. Can you see it?
Yes.
Okay, good. We are given a project that was undertaken by Mwamba Limited. We are given the activities and the preceding activities plus the durations of the project. And here we are told you draw a network diagram of the project, you determine the critical path, you also determine the project duration. You also determine the project duration. So how this preceding activity is the activity that must be completed before this activity can start. Before these activities can start, these ones, they must be completed. They must be completed. So how do we do it? How do we handle that? So in a minute, we can do that. I hope you can be able to access it from your other gadgets. From your other gadget and see how this diagram is going to appear. It is very easy. It is very easy. It is very easy. So this is how we work it out. Let me open mine. So the preceding activities, just a minute, just a minute. Well, page 9. So our network will start from the left-hand side, and then it will move like that. That is the starting point. That is the starting node. You start with a circle. So here, look here. activities A and B, if you look at activity A and B, they don't have the predecessor. Meaning that is all those two activities will be starting from scratch. That is the starting point for the project. They don't have any activity behind them. So we start with them, activity A and B. Activity A and B. So we shall have activity A starting. Activity B will also be starting. Once an activity has come to an end, you draw an event, and an event is a circle. You draw an event, and an event is a circle, like that. These are the starting activities. We don't have any arrow behind here. Behind this, we don't have any arrow, so they are starting from here. A starts, B also starts at the same point. Then we come here. After activity A has been completed, what happens? Which activity follows? We have already done activity A and activity B. We are now at activity C. Activity C starts immediately activity A has been completed. Immediately activity A has been completed, activity C will start. Now what you need to know or to be keen on, you look at these activities that are here, the preceding activities that we are given. Do we have an activity which C is combined with and that activity that has already been undertaken? In this, remember here we have a combination of BC, BC, EF, 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 DH, and all that. You look at where C is combined with another activity, and that activity that C is combined with has already been undertaken. So you can agree with me, we have activity B that is combined with C, and already activity B has been undertaken. So that simply tells you that activity C will start from the end of activity A, but it will be joined with activity B. It will start from A, and because it is combined with B, which has already been undertaken, so it will end where activity B has already ended. So they will merge there, they will converge there. So activity C will start from A, but it will end at B because they are combined. So these two activities must be completed before activities or other activities can take place. Before other activities, B and C, they are combined. So they must be meeting at a one point like that. So C will come to B like that. That is C, already taken care of. We go to D. D will start from A. We have another activity that D is combined with, and that activity has been undertaken. You can see here there is no D, there is no D, there is no D, there is no D, there is no D. Here there is D, but H, which is combined with the D, has not been undertaken. So that is not a point to concern. We cannot be able to merge with H because H is already not undertaken. So D will not actually be now moving to H. It is H that will go to D because H has not been undertaken. So we shall draw activity D from A. That it will not be that wrong. That is activity D from end of A. D will start because H has not been undertaken. We don't have H anyway. So that D will be like that. H, when it will be undertaken, it will come and combine with that later on. We are at activity E now. It also starts from A. And do we have an activity that has been undertaken? these that have been undertaken, A, B, C, and D, do we have any of these four which are combined with E? You look here. We have D, E. We don't have DE anywhere. So E, it is an independent activity. So there is no activity that will be combined with this, or there is no activity that has been undertaken that combines with E. You have it like that. We continue. Just move procedurally like that. Just move procedurally like that. We have done E. Now we are at F. F will start when B and C have been completed. Will start when B and C have been completed. The same case with G. G also starts when B and C have been completed. Let us start with F. When you look below here, do we have an activity which has been completed, that is E, D, C, B, and A, and it is supposed to be combined with F? Yes, we have EF. E has already been undertaken. Therefore, F will start after B and C have been completed, and it will go and combine with E. It will go and meet where E has come to an end. So this is how we are going to draw it. B and C, they were completed here. Once they have been completed, an activity F will start, which will go and meet activity E. Which will go and meet activity E like that. So we have that. We go to the next activity, which is G. We go to the next activity, which is G. Activity G starts after B and C have been completed. So do we have any activity that is combined with G and it has been completed? So do we have any of these completed activities from A to F? Do we have an activity that is combined with G? G here is combined with J, but J has not been undertaken. So that one we don't consider it. So G, for now, it is going to be drawn on its own. We are going to draw it on its own. It is J now that will come and meet it. It will come from B and C, and then we shall have activity G. Yeah? We shall have that activity G like that. That is activity G. Good. We are at activity number H. H starts from E and F, and then ask yourself, do we have an activity that is combined with H, and that activity has already been undertaken? So H, here it is combined with D. H is combined with D. So from H, which will start from EF, it will go and meet the end of D, where D has come to an end. So we shall have this EF. EF is here. And D, let me enlarge this one a bit. Let D move on to that point like that, so that this D and this other activity that we are drawing, they will have to meet. Where activity D comes to an end, this activity H will also come to an end at that point, but H will come after E and F have been completed. They will meet there. They will meet there. We are done with H. I starts from E and F. Do we have an activity I here, which has been completed from A to H? Do we have an activity from A to H which have been completed, which we need to combine with I? We don't have. We don't have. It is going to be combined here with R and K, but R and K, they have not been undertaken. So activity I will start from EF or completion of EF. Completion of EF is here. Just draw activity I like that. Just draw your activity I like that. Done. We go back to the table. We have here activity J, which also starts from EF. And you look, do we have an activity which has already been undertaken? All these have been undertaken up to I. Do we have an activity from A to I which has been undertaken, which will be combined with activity J? Yes, here we have GJ. Yeah? G has already been undertaken, and then it will combine with J. So this activity J will start from the completion of EF, but it will go and combine with G. Yeah? It will start from EF, but it will go and meet G here. Yeah? It will go and meet G here. So it will start from EF, which is here. Remember, E and F came to an end here. From EF, we are going to have activity J, which will come and meet activity G like that. To meet activity G like that. Now we are at activity K. It starts from DH. We have an activity that has been completed, which combines with K. Yes, we have activity I. Activity I, remember, has already been undertaken. So at one point, they will combine with activity K, the completion of activity K. Yeah? Because I has been completed, then K will have to go and join where I is. But this K will start after DH has been completed. After DH has been completed. DH has been completed here. It will come and meet activity I. This one we shall call it activity K. That one we shall call it activity K. That. Then the other one is what? Activity L starts after G and J have been completed. And do we have an activity or activities which will combine with L? And those activities have been completed. We have them here. L will combine with K and I, so that we can have activity M starting after they have been completed. So activity L will start from where G and J have been completed, but it will go and join activity K and I, so that we can have the three of them. So you will have it from G, J is here. Then they will go and meet where K and L have been completed, so that we can now have the last activity, which is simply your activity M, which will be your activity M. And that is how your network diagram will look like. That is how your network diagram will look like. Remember the rule. We need to end at one point. We need to start from one point. You cannot have a case whereby you are starting like this. A network diagram cannot start like this. No, it will have to start with 1, 0. Then it will have to come to an end at 1, 0. That is the rule. That is the rule. So after doing so, it is going to be very easy for us. I'm going to divide this into 2 like this. I'm going to divide them into 2. All of them. so that we can start with the earliest start time. So I want us to indicate the time estimates for each and every activity. For example, activity A, we have told it takes 7 weeks, so put there 7. Activity B, it takes 10 weeks, put there 10. Activity C, it takes 4 weeks, put there 4. Activity D takes 30, put there 30. Activity E takes 7. Activity F takes 12. Activity G takes 15 weeks. Activity H here takes 11 weeks. The next activity, we have the HI, takes 6 weeks. The next activity, J, takes, I don't know whether I've confused. A is 7, B is 10, C is 4, D is 30. E is 7, F is 12, G is 15, H is 11, I is 25. I is 25. Then J is 6. JK is 19. This is L. L is 25. And then this one is 2. They should be like that. Huh? Okay. You will assist, you will be patient a bit. I finish this, then you break for prayers. Ada, just a minute. So we are doing now the forward pass. Moving forward, we want to get the earliest start time for each and every activity. Yeah? So this is how we do it. Any project will start from 0. So the first circle on that particular point where on the left-hand side of this divided half circle, you put 0. You put 0. Any project will start from time 0. So 0 plus 7 takes or gives you 7. 0 plus 10, sorry, here I don't need to put fast. Don't put fast there. Don't put fast there. Where we have got 2 arrows pointing to the same circle, we need to determine the longest duration. So for us to come here, we can either move to A then C here, or we can go to with B direct. If we use B direct, it is going to take 10. But if we go to A and then from A we use C to arrive here, it is going to be 7 plus 4. 7 plus 4, 11. And this one is 10. You take the higher figure. You take the higher figure. When they converge, you take the higher figure, the higher duration. So 7 plus 4 is 11. This one is 10. You put there 11, the higher duration. So if we want to come here to know the figure that we are going to put here, it is either 7 plus 7, it points here, or 11 plus 12. 11 plus 12 is 23. 7 plus 7 is 14. You take the higher figure. In this case, we shall consider 23. We shall consider 23, the higher or the longer duration. To come here, you need again now to ask yourself, between 23 plus 6 and 11 plus 15, which one gives you a longer duration? 23 plus 6 is 29. 11 plus 15 is 26. So 29 is the higher figure. Put it there. To know the figure that you are going to indicate here, it is either 7 plus 30, 37, or 23 plus 11, which is 34. So 7 plus 30 is 37. Put 37 there. It's longer. We are now here. Here we have got 3 arrows that are pointing there. Either 29 plus 25, that will be 54. 23 plus 25, that is 48. 37 plus 19, that is going to be 56. So 56 is the longest. You put there 56. You put there 56, the longest. So you consider 37 plus 19, that is 56. 23 plus 25, that is 48. 29 plus 25, that is 54. So the highest of all those 3 is 56. You put it there. Then now you finish now. 56 plus 2 gives you 58. You are through with the forward pass. After you have arrived at the end, you start now again moving back by subtracting. This figure that you will get here, you will transfer it to the other side, indicate there 58 as well. Now you start subtracting backwards. So here we shall have 58 minus 2 gives you 56. What about here? 56 minus 25. 56 minus 25 gives you what? Gives you that 1. You put there that 1. To go back here, it is 56 minus 19. You get 37. To come back here now, you need to be careful because we have got 3 arrows that are coming backwards here, using this of J, that of I, and that of H. When we are coming back, if we have got 3 arrows that can take us to that particular event, you take the value that is smallest. When you are coming back, you take the smallest. When you are moving forward, you take the highest. So here we shall consider this. 37 minus 11, that is 26. 56 minus 25, it is 31. 31 minus 6, it is 25. Of these 3, which one is the smallest figure? The smallest is 25. That is what we indicate. If you want to know the figure to put here, 2 possibilities. Either you use 37 minus 7, which will give you 7, or actually there are 3, or 25 minus 7, which will be what? 17. 18, sorry. And then here, we need first of all to find this. We have got 2 arrows that are pointing here. It is either this 25 minus 12, that is 13. That 1 minus 15. That one, this one will give us what? 13. That 1 minus 15 is 16. So 13 is smaller. You capture there. So when we want to know here, we have said it is either that 7 minus 37, 25 minus 7, 18, or 13 minus 4. 13 minus 4 is 9. So the smallest is 7. Then now you finish here. It is either 7 minus 7, 0, 13 minus 10, 3. So you put there 0. Put there 0. Sorry, can't see there. Eh? When you are coming back here, you take now 7 minus 7 is 0. 13 minus 10 is 3. The smaller between 0 and 3 is 0. That is it. So when you are told to determine the project duration, you simply go to the last circle that we have, the last event. It has 58. So the whole project will take 58 weeks. When you are told to determine the critical path, the critical path, it is the path that is going to give you the 58, the longest path. the longest path. And how do you determine it? It is very simple. Go with the path where we have got identical values. Huh? Like here, this is 0, 0. But here it is 11, 13. So this one is not a critical activity. Yeah? So this one is critical because here we have 7, 7. When they are identical like this one is also a critical path. If you take that path, because here we have 37, 37, this is also a critical path. From there, we drop like this. This K is also a critical path because it gives us 56, 56. Then you go to the last one. It is giving us 58, 58, like that. The critical path, it is the longest path. If you add these particular time durations, 7 plus 30 is 37. 37 plus 19, 56. 56 plus 2 is 58. That is the path that is giving us the project duration. The others, if you look at this, if you add 7 plus 7 plus 25 plus 2, they cannot give you 58. So it is that path which is the longest, which actually will lead to the project duration. So the critical path here, it is the path that starts with A. From A, we go to D. From D, we drop with K. From K, we finish with M. That is the critical path. The critical path. That is the critical path. The longest path in a project. Like that. So Adam, sorry for that, Dide. You can take like 3 minutes for your prayers if you are there. As the others look at the question on page 2. You look at the question that is on page 2. As we wait for Adam, have a look at this question number 1B. I will come and we handle it before I give you one to try. Adan, are you back?
I'm back, yes, Mwalimu.
Okay, good. We look at this question, and I think if I do this slowly, without moving with the speed, I think you will be able to comprehend and be in a position to do other similar questions. So, just a minute. We are given here the project for a particular company. The activities are listed here, the preceding activities, and the preceding activities are those activities that must be completed. These ones must be completed before these ones can start. They must be completed before the others can start. And therefore, how do we present this information in a network diagram? Activity A and B, they don't have a predecessor. So those are the starting events. Those are the starting, activities, and they will start from the same event. These two activities, they will keep us starting, activity A and B. They start from the same event node, and they are going to be undertaken simultaneously. This is the start point. We shall start with activity A, then also activity B will also be undertaken. They will be done simultaneously. Then what happens after they have been completed? What happens after they have been completed? Look here, after they have been completed, after B has been completed, C will start. After B has been completed, C will start. So C will start at the point B has been completed. Do we have a case whereby C is combined with either A and B that have already been completed? Here, C is combined with E. So C is not combined with any of these two activities which have already been undertaken. So it will start after B has been completed. After B has been completed, that is the point, activity C will start. Activity C will start. You need to move as you take stock. So as we are speaking, activity A, B, and C, they have been undertaken. We go to activity D. Where do activity D start from? It starts from A, where A has been completed. When A has been completed, immediately D will start. Do we have a case where D is combined with any of A, B, and C, which have already been completed? You look at those activities that are combined here. There is nowhere D is combined with these three activities already completed. So D again, it will start after A has been completed, and it is not going to be combined. After A has been completed, activity D will start. Like that. Like that. We move on.
Yes, Mwalimu.
Activity E also will start after A has been completed. And activity E, does it have a pair which is combined with, and those activities have been completed? Are we going to combine E with any of this? We have here C and E. Because C has been completed already, then activity E will start from the end of activity A, but it is going to go and join with activity C because C is already undertaken. It will emanate from the end of activity A, and then it will rejoin activity C because E and C, they need to end at the same point. It will start from activity A, but end at activity C like that. And this will be your activity E, so that we can have E and C converging at the same point like that. That is how you handle it. I wish that you are taking my steps keenly. Every activity that you go to, look at whether there is an activity that it should be combined with, and that activity is already undertaken. If I go to F, it starts after C and E have been completed. Where the C and E merged, that is where activity F will start from. And do we have an activity that F is going to be combined with? But the point to consider here, that activity that F will be combined with must be completed. An activity that is already completed. So F, here it is going to be combined with H and J. But look here, H and J, they have not been completed. So they are not existing in our diagram. So F will just be drawn from CE. Then H and J, they are the ones that are going to come and converge where F has been completed. So F will start from CE because these two, they have not been undertaken. So F is going to be drawn from CE, waiting for these two activities to be completed and merge at that point where we have F. So we draw from this CE, we shall have activity F. Once it has been completed, it will stay like that. Then it will wait for the other two to come and converge here. We are done with activity F. We go to B, to activity G, sorry. Activity G, we are told it is starting from the end of B. From the end of B, we shall have activity G starting. Do we have activity G being combined with any of these activities completed from A to F? If you look here, G is not combined with any. It is not combined with any. So it will simply start from B and it will be alone. It will start from B like that. That is our activity G. From where B came to an end. G is sorted. Activity H will start after the completion of D. So where D has been completed, that is where H will start from. And then this H, is it going to be combined with any activity that has been completed? Yes, it is going to be combined with activity F, which is already completed. So activity H will run from the end of D, but it is going to go and converge where we have the end of F. It will run from the end of D. The end of D is here. Then it will converge with where F is ending. So you draw it like this. That is your activity G. Sorry, H. That is activity H. Good enough. After H, we have activity I, which starts from where F, H, and J are converging. But remember, J has not been drawn. So we shall skip I and go and tackle J Remember, J should come and merge here, join where F and H is. And J is starting from G. Yeah? J is starting from G. So we shall go to where G is. G is coming to an end here, and draw activity J from there so that they can merge here. Once they have merged there, now they can produce the activity I. Now they can produce the activity I, where H, F, H, and J, after merging, that is when activity I will be starting. So activity J is already handled. We go to activity K, which starts at the end of what? Activity G as well. Then now, activity K, it is supposed to merge with what? Activity I. Activity I is already drawn. Activity I is already drawn. So this activity K will start from the end of G, and then it will converge where activity I has come to an end. It will run from where we have G, and because K and I are converging, then this one will have to meet I where it is ending. So it will start from the end of G, but must go and meet I, so that now we can have I and K converging to produce the last activity L. So it will run from the end of G and meet activity I, that is our activity K. After activity K and I have been completed, we shall have our last activity L starting. And that will be the end of that network. That is the solution to part, that is the solution to part one of the question. This is how the network diagram looks like. We have obeyed the rules. We have one single starting point. We have one single ending point. We don't have these particular danglers and loops, and the circles are not intersecting each other. Actually, that is another rule. The circles should not intersect each other. They should be free. After doing that, we can insert the time estimates. We can insert the time estimates, and our time estimates A is 7, B is 10, C is 15, D is 17, E is 14, F is 9, G, the time estimate is 15, H, it is 7, I, it is 11, J, it is 12, K, it is 7, and then L, it is 9. So those are the time estimates. After doing that, you come and subdivide every event like that. Subdivide the events like that. And actually, you can record them. This is event 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have got 9 events. You just label them 1, 2, 3 to the last one. Then I told you in a project, we'll start from time 0. And when we are moving forward, we are determining the earliest start time. The earliest start time the project or an activity will start. And on any project will start from time 0. The first circle On that part that is to the left, you put 0. That is the starting point. Then activity A will take 7 days. Is it weeks or days? I think they are weeks. So if it takes 7 weeks, it will be completed after 7 weeks. This one takes 10 weeks, it will be completed after 10 weeks. Then here we have got 2 arrows that are pointing to this particular event. We want to know which one gives us a higher time estimate when we combine them with the predecessor. So to come here, it is either 7 plus 14, 21, or 10 plus 15, 25. So we take the higher figure when we are moving forward. You take the higher figure. What about here? It is 1 arrow, so it is 10 plus 15, 25. What about here? It is 1 circle, 1 arrow, sorry, that is pointing there. 7 plus 17, it is 24. Here, we have got 3 arrows pointing to this event. The arrow of H, the arrow of F, and this arrow of J. So which one will give us the highest time estimate? 24 plus 7, it is 31. 25 plus 9, it is 34. 25 plus 12, it is 37. So we write here 37. We write there 37. Then we proceed to the last event now. We want to know the time estimate, the earliest start time here. It is either 37 plus 11, 48, or 25 plus 7, 32. 48 is higher. Put there 48. And 48 plus 9 will be 57. Will be 57. Once you have done that up to the end, already you have the project duration. 57. 57. If time is given in weeks, 57 weeks. If it is in days, 57 days. Then let us move backward. The 57 that we have here, we transfer it to the other side, right there, 57 as well. Now backward, we subtract. Where 2 arrows are converging backwards, we take the smaller figure. So this is one figure, 57 minus 9 will be 48. This is 2 arrows that are coming here, 1 arrow that is coming here. 48 minus 11 will be 37. Now coming to this event, it is either we come back with the arrow of K or the arrow with the J. If we use the arrow of K, it is going to be 48 minus 7, which will give us 41. If we use this arrow of J, it will be 37 minus 12, which will be 25. So I will use 25 because comparing 41 and 25, 25 is a smaller figure, the smaller time estimate. Good. Coming here, it is only 1 arrow of F that comes back here. I will take 37 minus 9. (37 minus 9 class) (28). Put there 28. Coming back here from here, it is 1 arrow, that is the arrow of H. 37 minus 7, it is 30. Coming back here, it is 2 arrows, this arrow of C and this arrow of G. 28 minus 15 is 13. 25 minus 15 is 10. The smaller one is 10. Put there 10. Here, we have got 2 arrows that come back here. This arrow of D, this arrow of E. This arrow of D gives us 30 minus 17, which is 13. This one gives us 28 minus 14, which is 14. I'll take the smaller one, which is 13. We are now coming back to the last on the starting point. You will have either 13 minus 7, which will be 6, or 10 minus 10, which is 0. There you write 0. You take the smaller. Between 6 and 0, 0 is smaller, right? So the clue here is this. In a project, it will start at 0, 0. Then where it ends, it will end with 2 identical figures. So the project duration. The project duration is equal to 57 weeks. The critical path, and remember, it must be a path that is starting from the start point, and it must take you to the last event there. It should not be a path that comes and disappears in between here. You know, here we have got many paths. To move from the start to the end, we can take that upper path. We go to A, we go to D, we go to H, we go to I, and then we finish with N. We can come here and start with what? A, then we go to E, then we go to F, F to I to F. That is another path. We can have here, we start with what? A, we go to, I think that one we have used. We can start with the B, B goes to C, C to F, I, N. We have got very many paths. We can go to B, G, J, I, then we finish with L. But now, out of those many paths, one of them is the critical. One of them, only one, not all of them, only one. Identify the one that is going to be critical path. The activities that are on the critical path are known as the critical activities. When you delay any of those activities that are on the critical path, the project duration will also delay. The project will take more time. The other activities you can play along with them, but those critical activities, activities that are on the critical path, they are critical because any of them, when it is delayed, it delays the entire project. So to identify them, we said you look at the path that gives you identical earliest starting point and the earliest finish point, or the latest finish point. So here, obviously, it will have to start from here. This is the part that is giving us 10, 10. This one is 7, 19. So A is not critical. B is critical, giving us 10, 10. C is not critical because here we have 25, 28. But this one is critical because here we have 25, 25. D is critical. Then here, we need to test here. Is 25 plus 12 37? Yes. So J is critical. Don't bypass. Don't use this shortcut. Don't bypass this one. This one is also critical. Then after getting here, 37 plus 11 will give us 48. And actually we have 48, 48. This is critical. That is critical. So what you do, you will come here and summarize them for the examiner. Tell the examiner that the critical path, it is the path that starts from B, it goes to G, it goes to J, then it proceeds to I, then we finish with what? N. That is our critical path. By so doing, you get your full marks. You get your full marks. Understand how to do a very good network diagram. Understand how you get the project duration. You do the forward pass. Where they converge, you add the two time estimates, and then you pick the higher. You pick the higher time estimates when you are making a forward pass. When you are making a backward pass, You subtract the time estimates for each project. Where they converge, you take a smaller time estimate until you get here. You will know that you have done a very correct backward pass when you get 0, 0 here. When you come back and then you arrive at 0, 0, then you have done something wonderful. Yeah? You have done something wonderful. So, with those many explanations, I want to say the topic on network analysis is done. Complement with the notes that you have. Understand how to do this network, and also understand how to determine history. As you make the forward pass, the last time estimate that you get in the last event node, that is going to be your project duration. Come back up to the beginning, then look for those particular cases whereby you have got identical time estimate. That is your critical path. It must start from the start event to the end event node. And then we have other terminologies like the float. You just make use of the notes. The float, any activity that is not critical, it has got what we call a float. A float is just spare time. The time that you can delay that particular activity and the project duration will not be affected. Will not be affected. So you see here, these are the differences. Here are the floats. The differences here are the floats. You can delay those activities, but still your project duration will not be affected. So go around, do a lot of these practices, and then you are good to go. That is all about network analysis, unless there is a question.